Welcome to Math 65. Today we're going to talk about polynomials some more. So just adding to what we already know and kind of also summarizing too what we've learned. So just as polynomials can be added and subtracted, they can also be multiplied and divided. We started with multiplying and save division for another time. Oh yeah, no, we're going to start with multiplying today. We're going to save dividing for another time, not even in this class actually. So let's recall some of the properties we learned. I think we learned this all in 5.1, didn't we? Laws of exponents? Yes, we did. The product rule. So when you're multiplying, now we noticed when we add and subtract, the exponents did not change, right? But when we multiply, like, let's say we have x to the third times x squared. Who remembers what that is? X to the fifth. Good. So what can we say the rule is? What do we do with those exponents? We add the exponents. Exactly, that's the rule. The commutative property basically just means that if I'm going to multiply these, I can multiply the coefficients a times b, and then I can multiply the bases that are the same, the variable terms, x to the n plus x, or times x to the n, we would add those exponents because that's the same rule as the product law there. The distributive property means I'm multiplying this by this and this, so I would get a, b, x to the p plus m, right? Those, I would add the exponents. I would multiply the coefficients. The coefficients in that case are a and b, plus a times c, and then you would have x to the p plus n, right? You would be adding the exponents when you multiply the bases. That's the same thing as the product law. Now what happens when we take power to a power? So let's say we have x to the third and we square it. What do we get there? X to the sixth. So power to a power, x to the m times n. When we have power to a power, we multiply the exponents. And we did a lot of flashcards. If you look back at the 5.1 and 5.2, maybe 5.3 videos, you'll see that we did a lot of exponents and we did a lot of flashcards at the end. So this is just a really good review here. So when we multiply monomials, we're going to use the commutative property or the product rule. So what do you get if you multiply 3x squared times 2x to the third? 6x to the fifth. Why fifth power? Oh, the product rule. Okay, what about b? Who can tell me the answer to b? Yes, positive 40, because a negative times a negative is a positive. We're adding the exponents. Who can tell me what they think the answer is for C? Nine x to the 10th. Good, because we're squaring the 3, and then we're squaring x to the 5th. Okay, here, negative 5 to the 4th. Okay, I'm just going to write them all out. A to the 3rd to the 4th. B to the 6th to the 4th. C to the 4th. Okay, can we simplify that? Does anybody know what negative 5 to the 4th power would be? It would be 625. Yes, 625, because it'd be 25 squared, which is 625. And notice that it's positive. Why is it positive? If you write it out, you will have negative 5, times negative 5 times negative 5 times negative 5. That's negative 5 to the 4th. Okay, what's the exponent going to be here? 12. B to the 24th and C to the 4th. Good. That's a monomial. That's one term because there's the coefficient, there's each of the variables. They're all being multiplied. That's why it's called a monomial. There's no addition or subtraction separating those terms. That's one term. Okay, here we're going to use the distributive property. What do we get? 3 2x plus 12. Good. And here we're going to distribute. So we're going to multiply negative 7h times every single one. Can anyone tell me what they would get? Minus 7h, right? Because you multiplied it by 1. Okay. Yes. Now circle the expressions that are equivalent. So we could go ahead and simplify this, right? 2 cubed x cubed. 2 to the fourth times x to the fourth. 2 squared times x squared. If you simplify all of that, it would be 2 to the what power? 3 plus 4 plus 2 is 9. X to the also ninth, right? Okay, so here, this is 2x to the ninth. All right. Is this the same thing? 2x to the ninth? Yeah. Now we have to figure out, all of these have x to the ninth, but they all have different coefficients. What is 2 to the ninth power? Anyone know? Well, you could use your calculator. I'll show you how to use your calculator, how to find that. Turn it on first. I go 2, this little up arrow caret thing to the ninth equals 512. So here, this one, these ones are not equivalent, right? Any questions on that? I don't know how they got 192. I can understand why they would get 18. A lot of students forget and they'll multiply these. So that's why when we took it to the ninth power, we got 512. Okay. We also need to be able to multiply binomials and trinomials together. There are a couple ways to think about this, but they all boil down to using the distributive property multiple times. Doubling up the distributive property. Distribute the first polynomial to each term in the second polynomial, and then look at the resulting expression and distribute again. This time, distributing the term from the second polynomial to each of the terms in the first polynomial. This sounds confusing to spell out, but in practice, it's not so bad. Let's try an example. So if I were to say, I'm going to take this whole thing and distribute it to this and to this, that means I'm going to have 2x times x minus 4, and I'm going to have 3 times x minus 4. You see what I'm doing here? I'm distributing that whole binomial. Now, I know I'm going to have to distribute the 2x, right? And I'm going to have to distribute the 3. You see why I'm doing that? So what do I get when I distribute the 2x? 2x squared. Okay, here I get minus 12. Can I simplify it any more? Oh, there's some like terms in the middle, right? 2x squared minus 5x minus 12. Okay, we may not want to write out all the steps of the distributive property every time. So another way to think of this multiplication is that you can multiply every term in the first polynomial by every term in the second polynomial. Multiplying term by term, sometimes known as FOIL. Has anybody ever heard of FOIL? I didn't wear my FOIL t-shirt, but I have a t-shirt that says FOIL, Keeping Algebra Fresh. It's for, here, I'll just demonstrate. A plus B, let's say we have A plus B times C plus D, okay? FOIL stands for first, outside, inside, last. So first is A times C because they're in the first position. So A times C is AC. Outside means we go outside the two terms that are on the outside. A times D, AD. Inside means the two on the inside, B times C plus BC. And then last, that's the L, is going to be B times D. So you see every term of the first polynomial got distributed to every term of the second binomial. So we're going to multiply here. So another way of, actually, let me just even show you one other way. Some people like this. This is kind of like an area model. So if I say this is a length, this is a rectangle. This is a length of x and a plus 2 more. This is a length of x plus 3 more. If I want to find the area, x times x is x squared. Does everybody get why x times x would be x squared? Using our laws of exponents, we're multiplying. We're finding the area now, not the perimeter, right? What's x times 3? 3x. What's x times 2? What's 3 times 2? 6. Now, if I want to add this all up, you'll notice that right here I have some like terms. So I have x squared plus 3x plus 2x plus 6. Could I simplify that any more? What would I get? 5x plus 6. And by the way, this is called foiling or multiplying, right? We foiled it. When we get to chapter 6, we factor. We're going to be getting this trinomial and we're going to be putting it back into that form. Don't get overwhelmed about it just yet, okay? Now, if I want to foil this, I can use this area model or I can just go first. What's the first? Yes. Outside. Inside. Last. Minus 1. Because there's no x there, right? 1 times negative 1 is negative 1. Can I simplify this? What could I simplify it down to? 9x squared minus 1. Notice that the middle terms canceled out. Okay, when you're getting ready for factoring, this one is called difference of two squares. 9x squared is a perfect square. 1 is a perfect square. Notice that the two binomials, they look exactly the same. What's the only difference between these two binomials? Yeah, the signs. One's positive, one's negative. So later on when we get to factoring, I'll be bringing up difference of two squares. Now this one is a little bit tricky because you've got a lot going on. So we're going to be distributing the 2x to everything. And then we're going to distribute the negative 5 to everything. So instead of FOIL, this is like FOIL. You see why there's more than just an outside-inside job? Okay. All right. So 2x times 4x squared is 8x cubed. 2x times negative 7x is negative 14x squared. 2x times 3 is 6x. Is everybody with me so far? Now I'm running out of room and I'm going to do something fancy here. It's going to blow your mind. But I'm actually going to do the next one on the next line, just because I don't want to run into my other problem. So I have negative 20x squared, negative 20x squared. Well, look at that. I actually lined it up so that it's in the right position to add to the like term. Negative 5 times negative 7x is negative 35. Oh, no, positive 35x. I heard, yeah, I got it wrong. Negative times a negative is a positive, right? Okay. Negative 5 times 3 is negative 15. So now I want to combine my like terms. So I have 8x cubed is my leading term, my leading coefficient of this cubic function. Can you add those together and what do you get? Notice that the exponent didn't change. Why didn't it change? Yes, we're adding like terms. What about here? And then, good. And then we'll just do this last one here. So notice that what I'm going to have to do is I'm going to have to FOIL, and then I'm going to have to FOIL with this guy. It doesn't actually matter because this is A times B times C. It doesn't matter which ones you do first. So I could multiply, I could FOIL these, I could FOIL these, and then multiply by that. So let's just do the first two. So let's FOIL. X times X gives us 3x and 6, right? So I'm going to be multiplying this by x plus 4. And part of the reason why I was going to do the other two first is because I think it'd be easier to distribute this over that. Remember, it doesn't really matter which order, you know, like 5 times 6 is the same thing as 6 times 5, right? That's commutative property of multiplication. So I'm going to rewrite this as x plus 4 first times, what's this simplify to? And the only reason why I'm doing that is because I think it's, instead of distributing 3 terms over 2, I think it's a little easier to distribute 2 terms over 3. Does everybody make sense? I just changed the order. I just flipped it, okay? So now I have x times x squared is x cubed plus x squared minus 6x. Everybody with us on how we got that? Now we're multiplying 4 times everything. 4 times x squared is 4x squared, positive, right? Plus 4x. And now we're going to combine our like terms. X to the third plus 5x squared, good, minus 2x minus 24. There it is. That's a lot. Yeah, when we multiply basically 3 binomials, we want to FOIL 2 of them together, and then we're going to have to simplify that and then FOIL the third one in. So it's kind of like shuffling cards, right? You can't just like, you got to get them all distributed. Distributed, yes. Okay, let's see. Should we continue on or save this for our next video? Save it. Okay, let's save it. We'll pick this up in the next one because this is already 17 minutes, so there'll be a part 2.